One of the important theorems in calculus is called Rolle's theorem. Rolle's theorem says, let f be continuous on the closed interval a to b and differentiable on the open interval a to b. If f of a equals f of b, then there exists a c, that's going to be an x value, on a to b such that f prime of c equals 0. Alright, so let's try to interpret this. The first part of the theorem is really just trying to give you the stipulations, the things that must be true for this to work. So first it says let f, that's a function, be continuous on some interval. They're just saying it can be any interval you can pick, or they'll usually pick for you, but let f be continuous on an interval and differentiable on an interval. If you're curious why the difference between the brackets and the parentheses, the brackets mean a and b are included. The parentheses mean a and b are not. We can't ever take the derivative at endpoints, so that's why we can't include them on the interval for the differentiable part. So they're telling us that for the theorem to be true, we have to be talking about something that's continuous and differentiable on its interval. And then it says, this is the third one, third stipulation, if f of a equals f of b. Well, a and b are our endpoints. So all that's saying is our endpoints have to have the same y value. In other words, our graph would have to look something more like this as opposed to something like this. See, here the endpoints are the same height. They have the same y value, whereas here they are not. So there's three stipulations for Rolle's theorem. The first is that f is continuous. The second is that f is differentiable. The third is that the endpoints have the same y value. Now, if those three things are true, then somewhere on that interval, the derivative is equal to 0. So just visually, I wanted to give you a couple examples of how this works. Okay, if you notice, these endpoints have the same y value, and right about here, we would have a slope of 0. Same on this one. The endpoints have the same y value, and so we would have a slope of 0 in actually lots of places. Now, Rolle's theorem guarantees you that you're going to have at least one, but it could be more than one. But Rolle's theorem guarantees you there will be one. And then this last one, we obviously are on the same y value because they're on the x-axis. And then there's horizontal asymptotes, or place where the derivative equals 0, in two spots. So now let's move on and try an example. Does Rolle's theorem apply to the function x squared minus 3x plus 2 on the interval 1 to 2? If so, find the value of c such that f prime of c equals 0. So that first part is just asking us, does Rolle's theorem apply? Now remember, there's three requirements for Rolle's theorem. First, it has to be differentiable. Second, it has to be continuous. Third, the endpoints have to have the same y value. Actually, I'm going to go back to the first slide for a second because I had something there I wanted to show you. If you look down here, it's just some tips on looking for issues of being continuous or differentiable. As far as things being continuous, really the only thing you need to worry about is denominators. If something's going to make the denominator equal 0, it's obviously not going to be continuous there. So that's one thing you need to look out for. And for differentiability, you mainly just need to look out for absolute value, because that's going to create corners, or x to the 1/3, 2/3, 4/3, and actually anytime it's a fractional exponent and it's an odd number on the bottom, you need to look out, because that can either create cusps or it could create vertical tangent lines. But our red flags are denominators, absolute value, and x to the 1/3, 2/3, and so on. So as we look at this problem, none of those red flags show up. There's no denominator, there's no absolute value, there's no x to the 1/3 or 3/3 or 4/3 or whatever, nothing like that. So this function is continuous and differentiable. It's actually just a parabola, nothing that complicated. So we know it covers the first two requirements. The third requirement is that the endpoints have to have the same y value. So our two endpoints are 1 and 2. Those are given to us right here. So I take 1 and I plug it in the function, and you'll get 1 squared minus 3 plus 2 is 0, and you plug in 2 into the original function, and you'll also get 0. So all three requirements check out. Everything checked out. We're continuous, we're differentiable, and our endpoints have the same y value. So that tells us by Rolle's theorem that we are guaranteed to have a place where the derivative equals 0. So now we just need to find that spot. We'll take the derivative of the equation, set it equal to 0. Add 3 to both sides, and divide both sides by 2. So at x equals 3 halves, or you could call that c if you want, the derivative equals 0. Now just so you know, if any of those requirements aren't fulfilled, all you have to say is does not apply. All you have to say is does not apply. You don't even have to do the rest of the problem at that point. Alright, let's look at the second example. Does Rolle's theorem apply for f of x equals x to the fourth minus 2x squared on the interval negative 2 to positive 2? If it does, find the c value such that f prime of c equals 0. Alright, again, as far as continuous and differentiable, we just need to look for the red flags. Here there aren't any of the red flags because there's no denominator, there's no x to the 1/3 or 2/3 or anything like that. There's also no absolute value. So it is continuous and differentiable. So next thing we need to look at is if the endpoints have the same y value. So I take negative 2 and I plug it in that original function and I get 8. And I take positive 2 and plug it in and I also get 8. So this checks out. So Rolle's theorem does apply, which guarantees me that somewhere on the interval the derivative will equal 0. So I'm going to take the derivative, set it equal to 0. I need a factor. These have 4x in common, leaving me with x squared minus 1. Then x squared minus 1 factors to be x plus 1, x minus 1. So I actually have 3 places where the derivative is going to equal 0. 0, 1, and negative 1. One thing you need to make sure you check on is that all your numbers actually fall inside the interval. If some of them don't, that's okay, you just need to throw them out because they don't apply. But Rolle's theorem only guarantees you 1, so there may be times where you get 2 or 3 answers and only one of them is going to help you because only one of them is in your interval. But all 3 of these turn out to be in our interval, so we can use all 3 of them as our answer.